The global semiconductor shortage has been affecting many industries and sectors, but one of the most impacted is the cloud computing market. Cloud computing relies on data centers that use thousands of servers to run various applications and services, including artificial intelligence, AI, software. AI software requires specialized server chips that can perform complex calculations and process large amounts of data. These chips are in high demand, but low supply, due to various factors such as the COVID-19 pandemic, trade tensions, natural disasters, and increased consumer demand for electronics. The shortage of server chips has caused major challenges for cloud server providers and their customers who rely on AI software. According to interviews with the cloud companies and their customers, some of the problems they face are limited availability of AI server instances. Cloud server providers such as Amazon Web Services, AWS, Microsoft Azure, Google Cloud Platform, GCP, and Oracle Cloud have been unable to meet the demand for AI server instances, which are virtual machines that run on server chips optimized for AI tasks. These instances are often used by developers and researchers who need to train and run machine learning models. Due to the shortage, some cloud server providers have imposed quotas or restrictions on the number of AI server instances that customers can use or launch. Higher costs and lower performance. The shortage of server chips has also increased the costs and reduced the performance of cloud computing services. Customers who need to use AI software have to pay more for the limited AI server instances available, or settle for less powerful or less efficient instances that may not meet their needs. Some customers have also reported delays or errors in launching or running their AI applications on the cloud. Reduced innovation and competitiveness. The shortage of server chips has also affected the innovation and competitiveness of cloud server providers and their customers who rely on AI software. Cloud server providers have been unable to offer new or improved AI services or features that can attract more customers or differentiate themselves from their competitors. Customers who use AI software have been unable to scale up their projects or experiments, or explore new possibilities or opportunities with AI. This could hamper their growth and development in the long term. The global semiconductor shortage is expected to last well into 2022, which means that the cloud computing market will continue to face challenges and uncertainties. Cloud server providers and their customers who rely on AI software will have to find ways to cope with the situation, such as optimizing their existing resources, diversifying their suppliers, or investing in alternative technologies. The CHIPS and Science Act is a landmark legislation that aims to boost the U.S. semiconductor industry and its implications for AI and cloud innovation. The act was signed into law by President Biden on August 9, 2022, and provides roughly $280 billion in new funding to support domestic research and manufacturing of semiconductors. Semiconductors are essential components of many modern technologies, such as computers, smartphones, cars, medical devices, and military equipment. However, the U.S. has been losing its global leadership in semiconductor production and innovation, as it relies heavily on foreign suppliers, especially from East Asia, for 75% of its chip supply. This poses significant risks to the U.S. economy and national security, as well as its competitiveness in emerging fields like AI and cloud computing. The CHIPS and Science Act aims to address these challenges by investing in various initiatives to strengthen the U.S. semiconductor ecosystem. Some of the key provisions of the Act include creating a $52 billion fund to provide incentives for domestic semiconductor manufacturing and research. This fund will help attract private sector investment, create thousands of jobs, and increase the U.S. market share of chip production from 10% to up to 30% over the next decade. Establishing a national semiconductor technology center to coordinate federal research efforts and foster collaboration among industry, academia, and government agencies. The center will focus on advancing cutting-edge semiconductor technologies, such as nanoelectronics, quantum computing, neuromorphic computing, and photonics. Authorizing $81 billion over 5 years for the National Science Foundation to support basic and applied research in science and engineering fields that are critical for semiconductor innovation. The Act also creates new programs to train and educate the next generation of STEM workers and researchers. Enhancing the national security and resilience of the semiconductor supply chain by requiring regular assessments, developing contingency plans, and imposing export controls on certain foreign entities that pose threats to the U.S. interests. The CHIPS and Science Act is expected to have significant benefits for the U.S. economy and society, as well as its leadership in AI and cloud innovation. By boosting domestic semiconductor production and research, the Act will lower costs, create jobs, strengthen supply chains, and counter China's growing influence in the global chip market. Moreover, by advancing state-of-the-art semiconductor technologies, the Act will enable new breakthroughs and applications in AI and cloud computing that will enhance productivity, competitiveness, security, and quality of life for Americans. AI chip design is the process of using artificial intelligence technologies such as machine learning to design, verify, and test semiconductor devices. AI chip design can help optimize the performance, power, and area of chips, as well as accelerate the time to market and reduce the cost of chip development. One of the main applications of AI chip design is to use reinforcement learning to explore the solution space and identify optimization targets. Reinforcement learning is a branch of machine learning that learns optimal behavior in an environment by interacting with it and observing the rewards or penalties. By using reinforcement learning, AI chip design tools can autonomously converge to tape-out-ready solutions that meet the design specifications and constraints. Another application of AI chip design is to use machine learning to detect defects and anomalies in the chip fabrication process. By analyzing historical data and images of chip wafers, AI chip design tools can identify potential faults and mitigate them before they affect the chip quality and yield. AI chip design tools can also help with test program generation, verification coverage, and debug for first-time write silicon. AI chip design is not only useful for designing new chips, but also for migrating existing chips from one foundry or process node to another. AI chip design tools can help with porting the design rules, libraries, and IP blocks to different technology platforms, as well as optimizing the layout and routing for different process variations. AI chip design is a promising technology that can revolutionize the semiconductor industry by enabling faster, cheaper, and more efficient chip development. However, AI chip design also faces some challenges, such as the complexity and diversity of chip design problems, which require different types of AI algorithms and models to solve. The availability and quality of data, which are essential for training and validating AI models. The scalability and interoperability of AI chip design tools, which need to handle large-scale designs and integrate with existing EDA workflows and standards. The explainability and trustworthiness of AI chip design solutions, which need to provide clear and reliable feedback and reasoning for the designers and engineers.